All right, let's talk about a piece of the .NET framework that I think a lot of us use, but maybe don't really stop to appreciate: the cancellation token. Is it just another tool in the box, or is it something more? Something absolutely vital for writing solid modern apps? Let's dig in.
So let's just cut right to the chase with a big question. Is the cancel tokenization the most underrated tool in the entire .NET ecosystem? Now that's a pretty bold claim, right? So throughout this explainer, we're going to unpack that idea and see if it holds up.
To really get why the cancellation token is such a big deal, we have to jump in our time machine for a second. We need to see what the world of async programming was like before we had a standard way to just say, hey, whatever you're doing, just stop.
Before .NET 4.0 came along, things were, well, a mess. It was kind of the Wild West. Developers were completely on their own, trying to manually wrangle threads and inventing their own custom Boolean flags like, is canceled. This whole approach wasn't just clunky. It was a breeding ground for nasty bugs and really hard to find race conditions.
And the results of that chaos? They were painfully real. You've probably felt this before. Your app's UI just completely freezes because some background task gets stuck. And behind the scenes, you've got resources being held hostage, causing memory leaks. Your code base for managing all this turns into this tangled, unmaintainable nightmare. This was the exact problem that desperately needed a solution. And right into that chaos, Microsoft delivered a solution that gave us a standardized, really elegant way to handle cancellation. So it's time to properly meet the hero of our story, the cancellation token.
So what is this thing really? Well, at its core, a cancellation token is just a super simple, incredibly lightweight structure. Its entire purpose in life is to be a messenger. It carries one signal, hey, it's time to cancel, from the code that wants to stop to the code that's actually doing the work.
And the whole system is a team of two. First, you've got the cancellation token source. Think of this as the boss, the issuer. This is the object you create and hold on to. When you're ready, you call the cancel method on it. Then you have the cancellation token itself. This is the listener, the worker. It's just a lightweight token you pass around to your methods. It can't start a cancellation. All it does is listen for the signal from its boss, the source.
Okay, so that all sounds pretty good in theory, but how does the signal actually travel through your application? Let's break down the mechanics because it's actually surprisingly simple.
So it really all comes down to the simple four-step dance. First, you create your cancellation token source. Step 2, you grab its token and you pass that into your async task. Now, step 3 is the most important part. Inside your task, your code has to actually check the token every so often to see if it's been canceled. And finally, when you're ready, you call cancel on that original source object. That's it. The signal is sent and your task knows it's time to wrap things up.
But why go to all this trouble? Well, Microsoft was knocking out several big problems at once. This finally gave developers one single standard way to do cancellation everywhere in .NET. It's thread safe, so it kills those nasty race conditions we talked about. And it allows tasks to shut down gracefully, cleaning up their resources, which is just fantastic for making your apps more stable and scalable.
All right, that's enough theory. Let's see how this thing actually behaves out in the wild. How are you going to use a cancellation token in your day-to-day coding? The absolute classic use case is for stopping a background job that's just taking way too long. Think about processing a huge file, or running some super complex calculation, Or maybe waiting for a response from a piece of hardware that might never come. So if we look at the code, it's pretty straightforward. First, you create the source. Then, to actually send the signal, you just call cancel. But the real magic, the secret sauce, is what you do inside your task. You have to periodically check if cancellation has been requested. And then you can just call throw of cancellation requested. And this is cool. It throws a very specific exception that tells the system, hey, I stopped because I was asked to, which is a clean, expected outcome, not some random error. And this isn't just for your own code. All the modern .NET libraries are built with this cancellation pattern in mind. A perfect example is HttpClient. Let's say a user clicks a button to fetch some data, then immediately navigates away. You don't want that network request to finish, right? Well, you can just pass the cancellation token right into your API call and kill it instantly.
Okay, so we've seen it's powerful, and it's deeply integrated into .NET. But that brings us right back to our original question. Is it a true gem, or is it maybe just a little bit overhyped? Let's weigh the pros and cons. So on the underrated gem side, its biggest win is having this one unified model for cancellation across the entire .NET landscape. It's generally easy to use, and it is a beast at preventing resource leaks. But on the overrated side, look, it's not magic. The responsibility is still on you, the developer, to manually check the token in your code. For really quick, simple tasks, it can feel like a bit of overkill. And yeah, trying to trace a cancellation through a super complex call stack can sometimes make debugging a little tricky. So, knowing that, how do you make sure you're using it effectively? How do we make sure it always lands firmly in that gem category for us? Let's just quickly cover a few essential best practices. All right, 3 key things to remember. First, in any long loop or process, you have to check that token periodically. Don't just check it once at the beginning. Second, get comfortable with catching the operation canceled exception. Remember, this isn't an error to be afraid of, it's the signal of a successful, graceful stop. And finally, pass that token down the entire call stack. If a method you're calling can accept a token, give it one. Create a whole chain of cancelability.
So what's the final verdict here? Well, for any application where responsiveness and stability actually matter, and let's be honest, that's pretty much every application, the cancellation token is just an elegant, reliable, and honestly an indispensable solution. It really is the unsung hero that's quietly keeping your app running smoothly. And that really brings us to the end of it. We've seen where it came from, we've seen how it works, and we know why it's so important. So I'll just leave you with this question to chew on. In the code you're writing every single day, is the C cancellation token that unsung hero you might have been overlooking? Thanks for joining.